Okay, everyone, we are doing um, week 2, unit 3. Okay, let's go to your notes first. Okay, if you go to your notes on week 2, okay, this week we are doing revision of your year 11 motion, basically your Newton's laws. Okay, you should learn all this in year 11. Okay, but however, uh, I'm just going to go through a few example questions. Now, if you go to your page 2.2 on your notes, okay, now the task for this week is your textbook question 1.1, 1.2, and 1.3. Okay, the answers are in your distance education notes. Okay, now also you have to do your checkpoints question, chapter 1 and chapter 2. Okay, those those knowledges should be learned in year 11. Okay, so um, make sure you can do them. Okay. Also your work for submission. I know there's a lot of work, okay, but if you have high expectations of your end of year exam, you should do them all. Okay. However, if you don't have enough time, okay, what I recommend you to do is just do the checkpoints questions and your work, your weekly assignment. Okay, that's only if you don't have enough time. So, yep. So now let me do a few example questions for you. There are 8 example questions. Let's go with question 1. Okay. Um, okay. Now, okay. Have a look at question 1. Okay. A cyclist. Well, we can read. You can read it. Okay. Just remember in physics, when we're doing questions, try to highlight the important part. Okay. For instance, a cyclist moving at constant speed. Let me use red. Okay. Now, what does this mean? Okay. When it moves at constant speed, it means the acceleration is 0. Okay. On a straight line, flat road, okay, and experience a retarding force. Okay. This is for another word to friction force. Okay. The word is retardation. Okay. Retardation is opposite to acceleration. Okay. So, uh, so a friction force of minus 120 newtons. Okay. Now, the driving force generated by the cyclist must be multiple choice question. So what's happened is, okay, okay, if I have a mass, okay, and we have a resistance force of minus 120 Newton, and the acceleration is 0. Okay, so what it means, okay, the driving force, we have a driving force. Okay, the driving force must be the same. Okay, otherwise, there will be a net force. They won't be. They will be different. The acceleration will be different. So the driving force must be same as the retardation force, that's the friction force, which is equals to, this is your answer. Okay. The important part of this is, yes, okay, sorry. Okay. Before we start, just remember to organize your cheat sheet as you go through all the questions. Okay. Remember, you can have a A4 single page cheat sheet. So in your cheat sheet, in this chapter, okay, write down Newton's 3 laws. Okay, go to your notebook, write down Newton's laws, Newton's first law, second law, and third law on your cheat sheet. Okay, because you're always going to use it. Sometimes in the exam they ask you what is Newton's first law. If you have it on your cheat sheet, just copy it down. Now, Let's go to the second question. Okay. This question is also about Newton's first laws. Just let's read down the question. Okay. So we have a car and yep. Okay. Now let's read the question. So a car of mass 116. So let's write it down. Okay. So I have the mass is going to be 1,600 kilogram. Always remember the unit. The trailer, if I put it up, okay, the trailer has mass 2 is 1,200 kilograms. Okay, now the driving force changes the engine power to maintain a constant speed. This on a straight road, the total reduction force, the friction force on the car is this, and on the boat and trailer is this. Okay, again, constant speed means acceleration equal to 0. Also means the net force equals to 0. So calculate the driving force exerted by the car at this speed. So let's draw a diagram. Okay. Mass 1, okay, which is your car, connect to mass 2, your trailer, is moving at a constant speed. Okay, so the acceleration is 0. The net force is 0. Okay, now what's happened is, okay, the friction force on the car is this much. Okay, and the trailer, friction on the trailer is this much. Okay, now it's simple. So we have so what's the driving force? What's the driving force here? Okay, so the driving force must be the same as the friction force. Otherwise, we will have the net force won't be 0 anymore. Okay, so your driving force must be this plus that. Okay, simple and easy. Okay, just another thing. Okay, do you still remember how to convert kilometers per hour into meters per second? The idea is 72 kilometers per hour. Okay, so what you do is divide by 3.6, a shortcut. Okay, so use your calculator. Going to be 20 meters per second. Okay, this is a shortcut how to convert kilometers per hour to meters per second. Just remember that. Okay, if you don't know that, also write this down on your cheat sheet. So whenever you're doing questions, you should have your cheat sheet beside you. So if you figure out something you don't know, write it down. Okay. Now let's go to question 3. Okay. Now, okay, again, let's read the question. I call this question 3. Okay. So Amelia, someone who has a mass of this, is skydiving, the air pressure on her. Well, just read it. Okay. We have air resistance. We have the distance fallen. Okay, she fought 400 meters. Then she reached terminal velocity. Okay, now terminal velocity means the constant velocity. So when it reaches after, so at this point, after this point, okay, afterwards, okay, the velocity will be constant. Okay, velocity is constant. So what does it mean? Acceleration will be zero, the net force will be zero. Okay, and continue to fall at constant speed. Okay, until she opens her parachute. So let's look at the question. What is the magnitude of net force on her afterwards? So we know afterwards the net force is zero, because if you look at here, because it's terminal velocity and she moves at constant speed, acceleration will be zero, the net force will be zero. Okay. So, yep. So the net force will be zero. Okay. Sometimes in an exam question, they give you a lot of information, but focus on the question. The question is on net force, so just subtract the useful information. Okay. Constant velocity, acceleration must be zero, net force must be zero. The answer will be zero. Now let's go to the next question. Don't save it. Okay, now let's look at question 4. Question 4. Okay, let's read the question first. Okay, so we have a mass equals to 0.5 kilogram. Okay, then here, it's pointing vertically up, so this is your positive. Okay, now the gunpowder burns for a period of 1.5 seconds and provide a force. Okay, so the upward force upward will be 22 newtons. Okay, the mass is very small. The mass of gunpowder is small. Yep, this is a rocket. Okay, and so there's no air resistance in this question. Okay, now let's have a look what they're asking. Okay, the magnitude of resultant force on the rocket. Now the idea is, let's draw a diagram. Okay, so if the rocket is here, the mass is 0.5 kilogram. Okay, now we have an upward force of 22 Newton. Okay, now think about, is there any other forces? Okay, the answer will be yes. Okay, always remember gravity. Okay, mj. Okay, so the idea for gravity is, in the exam, your gravity will be 10 meters per second square. Okay, that's in the VCA final exam. So, however, in your textbook, the questions in your textbook use 9.8. Okay, so for now, I just use 10. I just use this one. Okay, so which is your mass times gravity, 5 newtons. Okay, so what's the resultant force? Okay, resultant force means net force. This is another way to say net force. So the net force, okay, will be sum of all forces which is positive 22 take away 5. Okay, 5. Use a calculator or 17 newtons. That should be the answer. Now let's go to the next part. Okay, so if you forgot about gravity, write down it in your cheat sheet. Okay, always remember gravity. Now question 5. Okay, let's have a look. Okay, so we have an insect collide with a speeding car and is squashed against the windscreen. Okay, so the insect exerts a force of F1. Which of the following statement best describes the magnitude of force Fw? Okay. The force exerted by the windscreen on the insect. Okay. This is so testing for Newton's third law. Okay, so just let me explain it. If you have a look at Newton's first law, so the idea is, say this is me, okay? And someone, actually, just give me a second. Okay, say if I been okay, say if I've been a car accident. Okay, a car just crashed into me. Okay, and what's happened is, okay, for Newton's third law, okay, the force during this collision, the force I exert on the car, and the car should be the same as the force the car exerts on me. That's an action. Well, should be an action and a reaction force. Okay, so in the other word, I can say, okay, the car hits me, or I hit the car with my body. So that's Newton's third law. So in this case, these two forces should be the same. So that should be your answer. Okay. Now let's go on to the next question. Okay, so he is sitting on a chair. Okay, he tells his friend that, okay, the chair is exerting an upward force on him, okay, equal to his weight force. Then Albert, the other guy, claims that the two forces are equal because they are two paths of an action-reaction pair. Is him correct? Yes or no? Okay, so okay, it's an explanation question. Okay, in the exam, this explanation question perhaps takes 4 marks. Okay, now, because it mentioned action and reaction pair, that's Newton's third law. So, in order for you to get 1 mark, okay, is to write down Newton's third law. Okay, so Newton's third law states. Okay, and copy it down from your cheat sheet. Okay, copy the whole definition down. Okay, then, okay, in an explanation question, you should you can draw a diagram. Okay, what happens? You can draw a chair. sorry, just draw a block will be fine. Okay, just draw a block. Okay, now, okay, so the force acting on the chair will be it's the weight force. Okay, now the common misunderstanding of this question is, okay, so I label this as weight, I label this as F. Okay, they should be the same. Okay, but okay, the action reaction pair should be okay, sorry, takes a little bit longer. Okay, sorry, the idea for this question is, okay, if you look at the question, okay, the chair is exerting an upward force. Okay, so if the chair, okay, let's label this the force chair exerts, okay, is a pair, okay, it's an action and reaction pair. It's an action and reaction pair with the force, okay, Abraham exert on the chair. Okay, now also, okay, his weight force, okay, is an action and reaction pair with the force because weight force is the force planet Earth exert on Abraham. So, so it's a force. Okay, so let me make it clear. Okay, the weight force is force planet Earth. Okay, exert on Abraham. Okay, so the reaction pair of the weight force should be, okay, the force, the gravitational force, okay, on the planet Earth exert by Abraham. Okay, so these two is a pair, reaction action pair. So these two is a action and reaction pair. So in the other word, okay, the chair is the force that the chair exerts is not a reaction and action pair force with his weight force. So he is wrong. Okay, even through. Okay, so yeah, so he is wrong. Okay, that's right. Abraham is wrong. It's wrong. Okay, so yep, even through the magnitude are the same. Okay, however, they are not an action and reaction pair. So Abraham is wrong. So in the exam, you get 1 mark to mention Newton's third law. You get another mark to mention that Abraham is wrong. So another mark to mention that the action and reaction pair force, okay, for the force exerted by the chair. Okay, and you get another mark to mention this. Okay, so that's normally what's happening in the exam for explanation questions. Okay, so yeah, we talk about that later. We talk about how to answer explanation questions in the year. Okay, so now let's Now let me stop it first.